So far, we have seen various techniques using which we can check if a particular number is valid perfect square or not, right? Now, let's quickly write the binary search based algorithm that we have discussed, right? Let's write the C++ solution for the same approach. For that, here I have created a new file, valid perfect square, and I have added the class and the function and calling of that function logic as well. Okay, now let's just add more meaning to this function name that we have defined here. Is valid square using binary search. Okay, and let's just make sure that we are calling the same function here as well. It's just that we are going to use binary searching technique for checking if a particular number is valid square or not, right? That's the reason why it gives much more contextual readability to the user. So here, as part of the base cases, if at all if the number that is given by the user is less than 0, obviously it is not a valid square. In that case, we will simply return false here itself. And the other case is else if at all the number that user has passed is equal to 1, or if the number that user has passed is equal to 0, obviously 0 square is 0, 1 square is 1, right? So here we will simply return true itself. Now let's try to write the logic for any other number. So here, since we are going to use binary search, let me just define the range variables for the binary search. Here I am going to initialize start with 1. Similarly, end I am going to initialize it with whatever the number that user has passed itself. Similarly, let me just define middle. This I am going to initialize it with -1 right now. Now, just like in any other binary searching implementations that we have done or the problems that we have solved, we will simply run a loop as long as the start is less than or equal to end. We will calculate the middle. Middle is nothing but the start plus end divided by 2. Okay, we have got the middle. Now what we will do, we will simply multiply middle by itself. So we will get the middle square. If this is equal to the number that user has passed, that means this number is a valid square. In this case, here itself we will simply return true. Okay, that is done there itself. If that is not the case, that means if at all the middle multiplied by middle is greater than whatever the number that user has passed, and the other scenario is obviously middle multiplied by middle is less than the number that user has passed. If at all the number that we are passing is smaller than middle by middle, middle multiplied by middle, then it is basically the number is the squared value of middle is greater than number. That means it should be somewhere on the left part. For that, we will simply update end with middle -1. In obviously the other case, we will update the start with middle +1. So middle +1. Okay. Now, once we are done searching in all the possible ranges, if at all if we hadn't found anything, any middle value which was yielding when it is multiplied by itself, if it is not yielding the number, we would have come out of this loop. Here we need to return false, indicating that the value is not a valid perfect square. Remember that it is a very simple implementation. The starting value is 1 and ending value is, in the worst case, it could go till number, but it will never go beyond that number. Obviously, it will always not go more than number divided by 2, but it's just that we have initialized it with num. Okay. So that is what is valid perfect square using binary search. Now anyway, we have added the calling of this function as well, right? So the number that I'm passing is 16. 16 is a valid square, right? 4 square is 16. So if I run this right now, true is what we should get, which is nothing but 1. 1 is nothing but true in CPP, right? So that is perfect. Let's just say I have passed -16. -16 is never a valid square because the squared values will never go less than 0. So if I run this right now, 0 is what we should get, indicating it's false. Okay. And the other scenarios are obviously, let's just say 225. 225 is nothing but 15 square. So if I run this right now, 1 is what we have got. Similarly, let's just say I want to test for 100. So if I run this right now, 1 is what we have got. Okay, and any other scenarios like 0 and 1, anyway we have handled that logic in the else if condition itself, right? So 1 is what we have got. So whatever the solution that we have written for checking if a particular number is valid perfect square or not using binary search is working absolutely fine. If at all, if you want to check out the code for brute force approach that we have discussed as well, you can use the link in the description. You can go there and you can check out the solution there as well. Okay, so anyway, that's it for this checking of valid perfect square or not. I'll see you in the next problem.